All right, continuing where we left off with the basal nuclei. This is another really important one for you to understand that everything we know about this, we know about it because of specific diseases, and the one that I'm going to harp on the most is going to be Parkinson's disease. This area is really deep in the brain. When it starts to break down, you end up being unable to control your movements, initiate your movements as well. So we know that it has a part to play in regulating your movements and initiating your movements, but we still have a lot more to learn about this particular area. Okay, skipping a whole bunch. Now, here we have a sagittal section of the brain so that we can start to look at areas of the midbrain and then the brain stem. So we're going to start leaving the, we're going to do some of the midbrain stuff running up through here. And then we're going to leave the cerebrum behind and get to some of these other areas off over here. But so cerebrum was all of this stuff that we just finished with all of those motor things and sensory things. It had our frontal lobe, our parietal lobe, our occipital lobe, temporal lobe, which you can see a little bit of that hanging down off over there. The insula, which is kind of on the other side of the corpus callosum right there. You can see one of the lateral ventricles right there. Behind the septum pellucidum, that is. So now what we're going to start talking about is the thalamus, the hypothalamus, pineal gland, otherwise sometimes called the epithalamus. And so that's where we're heading. So first up, thalamus. When it says relay station, what that means is it's taking information from either other parts of the brain or other parts of the body, and it's sending them to the appropriate parts of the cerebrum. One of the things that's really important about the thalamus is because there is so much information coming at the cerebrum, is the thalamus is deciding what's important for the cerebrum to actually be made aware of. And it's only sending the stuff that it considers to be important. So it's sort of editing the information. If you've ever heard of inattention blindness, that is the result of the thalamus filtering out information that it deems to be unimportant because your brain, your cerebrum specifically, just can't deal with all the information that's coming at it all the time. So the thalamus is a filter. Hypothalamus is critically important. Along with the medulla, the hypothalamus is arguably the most important part of the brain. So overall homeostasis, it's regulating stuff like your sodium levels, your potassium levels, your water levels, glucose levels, controls the autonomic nervous system. That would be your sympathetic and your parasympathetic systems. And that's because it helps to regulate your pituitary gland, which means it's also regulating pretty much your entire endocrine system as well. It's the center for the emotional response, especially the really strong emotions like fear and anger. Kind of already talked about homeostasis, but yeah, regulates body temperature, food intake, hunger, water balance, thirst, sleep-wake cycles, and already mentioned the endocrine system thing. I'm going to blow past her. I hate to do that. It's a really good story, but just in the interest of time. Pineal gland, this makes melatonin, which is part of your circadian rhythm. You secrete more melatonin as it starts to get darker. Melatonin tends to make you sleepy. The one thing that I always stress when it comes to melatonin is, one, as a supplement, it is not FDA regulated, and independent labs usually don't test companies that make melatonin, so be very wary of any melatonin that you're buying. Try to make sure that it is safety tested by an outside company. But two, melatonin can be a very beneficial thing to take if you are ever flying someplace that is multiple time zones away from you and jet lag is a real issue. Melatonin can help you get to sleep. Also, if you're ever doing shift work and you used to work the day shift and all of a sudden you get switched over to the night shift and you're having trouble getting back into a sleep rhythm, melatonin can help you start to overcome that. So there are real times where melatonin can be a helper. Okay, coming on down to the midbrain, yet another, we just got neurons passing back and forth. It's sort of like a highway system. Part of the midbrain is the cerebral peduncles, which are these little columns running right through here that are supporting the brain itself, essentially. Corpora quadrigemina. I've always loved these because to me, they look like little butt cheeks. When you pull the cerebrum back from the cerebellum, it looks for all the world like the brainstem is mooning you, and that is the corpora quadrigemina. The butt cheeks that are looking back at you have a top and bottom parts to them. So the top part is the superior colliculus, and those are our reflex centers that if you ever see something out of the corner of your eye, your head is going to automatically, reflexively turn to look at that thing that is you're seeing out of the corner of your eye. The inferior colliculus, also reflexive head movement, but that's in response to you heard something out of, well, not the corner of your ear, but hopefully you get what I'm saying. Okay, next we have something that links back to the basal nuclei that I started talking about earlier in relation to Parkinson's. So remember, the basal nuclei were about initiating and helping to regulate movement. Substantia nigra also plays some role in that. We again know that once again because of Parkinson's disease. In people who have Parkinson's disease, the substantia nigra starts to degenerate, and as a result, it stops producing dopamine like it's supposed to. Levodopa is one of the go-to treatments for people, especially in the earlier stages of Parkinson's, and it's because this part of the brain's not producing the dopamine like it's supposed to. So, again, we know that it has something to do with movement. We know that this area is suffering when Parkinson's disease is at bay, but it's really hard to study this particular part of the brain. Okay, pons. Pons is the largest structure that we've really got going on in the brainstem. It's this area right here. It helps smooth the transition between breathing in and breathing out, but it does not have ultimate control of breathing. That's the medulla's job. The medulla oblongata is the full name. This is, again, that reptilian part of the brain that really keeps you alive. This controls your heart rate. Therefore, it helps play a role in blood pressure regulation. It controls vasoconstriction versus vasodilation, which once again also helps control your blood pressure. Both of those things, heart rate, blood vessels, help to make up the cardiovascular center, which is contained within the medulla. The medulla has ultimate control of your breathing. Whenever your carbon dioxide levels get to be too high, your medulla is going to make you breathe, whether you want to or not. You really don't have a say in the matter. The medulla and the hypothalamus both are going to be working together, again, just to help keep you alive, essentially. The medulla is the inferior most part of the human brain. It is just above the spinal cord, and again, arguably the most important part of the brain. If you damage the medulla, you die pretty darn quickly. Cerebellum. This part of the brain, there are actually people who are born without this, and they can go their whole lives and not know that they have it, or go many decades and not realize that they don't have it. The cerebellum essentially sort of makes you graceful. It helps make all of your movements have more flow to them. Everything about the cerebellum is subconscious. We do not know everything about the cerebellum. There was a study that came out fairly recently that shows the cerebellum does seem to also play a role in memory formation, but mostly it seems to be about movement. Oh, there's a disease. Ooh, I wonder if I linked to it. Oh, and I won't be able to do it with this little thingy. Hold on. Hold on. I can't see my stuff. Pointer options. Arrow. Automatic. Okay. Sorry, that took me a little bit to get to it. So, like this is titled, I wish I picked a better video than this, but cerebellar hypoplasia means that the cerebellum does not form correctly. You can find a whole slew of different cat, dog, even human videos where the cerebellum doesn't form correctly, and notice that the movements are very erratic. I'm going to actually mute them. Eventually one of these cats gets up. I don't remember which cat, and you will notice very clumsy. Oh no, poor kitten. They don't get hurt, but notice nothing is graceful as they move around, and that's because without a cerebellum, you can't move gracefully. So very clumsy, lots of falling down. That's basically what the cerebellum helps to prevent on a normal sort of day-to-day. Y'all don't need to see that sort of stuff. Okay. Anything else? Yes. Still got to keep going. Got to go fast. Okay. Limbic system, sort of talked about this earlier. Emotional brain helps you form memory. Some of the more important parts. The amygdala is sort of a little structure in the brain that controls the emotional brain, if you will. Learning to control the amygdala is something that a lot of us are not very good at anymore. And I will throw myself under the bus there and say I am definitely not. I have some anger management issues of my own at this point, and that means I'm not controlling my amygdala as well as I'm supposed to. As you look at this picture right here, every time, at least in my experience, every time a mom gets a new baby, they get so excited about Christmas because it's baby's first Christmas and we're going to take the baby to go see Santa and we're expecting these wonderful, heartfelt memory pictures that we're going to get. And no, this is the reaction the first time our kids see Santa Claus, and that's because this dude is creepy. Let's be honest about him. He's wearing the most unusual clothes you have ever seen on a person. He's got full facial hair, so you can't really tell what he's thinking. We throw our kids on his lap with no warning, and so our kids are going to be freaked out. The amygdala tells them, stranger danger, you should be scared of this person, so this is going to be their reaction. This reaction, they have no control over this. The amygdala is telling them you should be afraid of this person. And so that's why they are afraid of that person. If you have an innate fear of something, whether it's spiders or bears or AMP tests, the amygdala is what's making you afraid of those things. The hippocampus, the little seahorse. It's the part of the brain that helps you convert short-term memories into long-term memories. And we know this because, I don't know if you guys have ever seen that movie 50 First Dates from way back in the day with Drew Barrymore. There are people out there who really don't have a hippocampus. EP is one such gentleman. I don't know if he's still alive. I really need to look him up at this point. But his hippocampus was damaged and he has formed no new long-term memories since World War II. And it's because without a hippocampus, you can't do that. You live in the present. And so a researcher and a journalist went to interview him, and they said he ate breakfast 5 times that day because he kept forgetting that he just ate breakfast. So that's how important the hippocampus is for you. Okay. Psychosomatic illness is not the same thing as being a hypochondriac. Hypochondriac is like, oh my God, I just read about rickets. I must have rickets. No. Psychosomatic is, again, I have anger management issues when I'm driving around in Fort Worth and I've been cut off like 85 times by somebody doing 110 miles an hour and I'm starting to get really angry about it. My blood pressure gets high. The level of stress hormones I'm secreting gets high. That can lead to hypertension, which is a real illness driven by my anger and anxiety as I'm driving in those places. So psychosomatic is your emotions are actually starting to make you sick. And so that's what a psychosomatic thing is. And unfortunately, especially since the COVID pandemic, we're seeing a lot more of that, where people are sort of living, dwelling in their depression and anxiety, and it's really taking a toll on their physical health as well. The reticular formation and the reticular activating system are designed to help filter the information that gets to your brain. Thalamus plays a pretty big role. And keep you conscious when you're supposed to be conscious and help you get to sleep when it's time for you to sleep. Yay. After that, it's brainwaves, and you guys have a different video to help you get through brainwaves.